Hello and welcome. My name is Duncan. I'm an architect and an environmental design consultant. And in this challenge, I was joined by Edith Kanana, a quantity surveyor and a cost control expert. Together, we present this innovative solution that we dub a healthy wall, breathing wall, that is made of oblique fence for healthy and insect-free living. In many low-income house settings, poor ventilation and mosquito-borne diseases like malaria remain a major challenge. Windows are often closed for fear of mosquitoes, and in some cases, buildings do not even have windows, leading to poor indoor air quality and heat buildup. We asked ourselves how we could improve airflow and block mosquitoes at the same time. And our solution was a breathing wall, which adopts a passive ventilation strategy using oblique vents and fiberglass insect mesh. So we took a typology house, like the one shown on the screen, that is made of mud wall and corrugated roofing sheet. We introduced two levels of ventilation, a bottom inlet and a top outlet. So the system of making the hollow fired brick fence adopts a 200 by 200 by 100 mm millimeter block fit, which is double layered, and in between the layer, fiberglass insect mesh is pressed. So the inlet, which is pressed 300 mm above the floor, and the outlet is pressed at 1500 mm above the ground. That gives a difference of approximately 1 meter. The 1 meter difference in height needed us to calculate the pressure difference between the inlet and the outlet, and we were able to work out the air change rate, holding a constant of 1.2 by 200 mm inlet and a 600 by 1.2 outlet for a standard loom that measured 2.7 by 3 meters by 2.4, and the air change rate was promising at 0.89, with the following assumptions made: that outdoor temperature was 20 degrees Celsius and indoor temperature at 25 degrees Celsius. So that is converted to Kelvin, and then the gravity was assumed to be 0.981 meter per Newton per meter square. The other advantage with our solution is that fired brick are inorganic, that makes them termite resistant. You'll find that a mud house is mainly infested by termite, and therefore adopting a fired brick would reduce the deterioration of this material and give it a larger lifespan. In terms of locating the vents in the house, we did them to enhance for cross ventilation as shown on the screen. Then our health expert was able to advise us on the costs. And the cost incurred in this case would be to demolish a space to fit in the vents. Demolition costs per square meter, which was at around 200 shilling for 2 meter square, bearing in mind that this is mud walls, so it is quite easy. And then the installation of oblique fence and the mesh cumulative would read to around 8,800 Kenyan shilling. And in total, we anticipate that ventilating the typical house used would cost approximately 9,000 as the quantities are shown. We therefore feel that the breathing wall bridges the gap between healthy air and insect-free living, making it ideal for low-income and climate-responsive contexts. It is simple, it's scalable, and it's smart. And we would welcome partners to help us to bring this idea into as many homes as possible, preferably if it's successfully piloted. Thank you so much for watching and listening to our presentation.